Good evening, members. You're all welcome to our March CPD. I hope you all had a nice day amidst the pandemic that's actually affecting the whole world. Following the President's directive to have all in-person meetings cancelled, we are having to have our webinars and to have our CPDs using the Zoom technology. You're all most welcome. And thank you for attending. Just to take you through, you can send in your questions through our email address, administrator@isaca.or.ug, or using the chat. Maybe just to take you through, we already had some upcoming events, which were cancelled, like the She Leads Tech awareness and mentoring program that was, we had to cancel it, but surely we shall communicate another date in the future. And maybe just to also let you know, we have a data analytics and training workshop that will take place in April between the 28th and the 30th. Hopefully by then, we shall be safe and good to go for the in-person meetings. Well, even if we shall not have them then, I'm sure we shall have a solution. Perhaps use the same online method to have it delivered. I think I can introduce to you our presenter for the day, Mr. Bernard Wanyama. Mr. Bernard Wanyama is a seasoned professional in the IT industry with a strong focus on IT service deliveries and cybersecurity, information security, and systems integration. He has over 15 years of industry experience and has previously held IT service management roles in various organizations and also done work both nationally and for international companies. Well, Mr. Bernard Wanyama, I'll hand the floor over to you. Please take us away.
Thank you very much, Emily. I hope I'm audible. So thank you for that introduction, Emily. Good evening, everybody, and thank you for joining us today amidst the different challenges and inconveniences of this COVID-19 crisis. I will take us through this presentation this evening, and we'll be looking at the security challenges around cloud computing and how we can address them. So for purposes of our learning, the objectives for this evening will be as follows. Upon completion of this session, a participant should be able to, number one, understand the importance of cloud computing technology to enterprises as an enabler and a pillar for digital transformation. Number two, understand common cloud computing service models such as infrastructure as a service, platform as a service, and software as a service. And then number three, appreciate the security challenges posed by cloud computing operations. Number four, understand the importance of security models such as the shared responsibility model and the zero trust model in improving cloud security. And lastly, understanding the key controls for managing risk in cloud computing deployments. So I would like us to take note of these and evaluate at the end of the session if we have covered them well, so that we can have feedback on that. So our agenda for this evening will be as follows. We'll look at an overview of cloud computing. Then we'll go to the risks around cloud computing as a technology. We'll look at cloud security models that offer a way of thinking and approaches to implementing security in the cloud. Then we'll look specifically at the controls, the key controls that can be applied in a cloud computing environment. And then we'll wrap up with resources and a way forward on what I think are the key steps to take for an organization that's on the cloud journey. So cloud computing does not exist for its sake, but it's largely seen as a driver and as a pillar for digital transformation. All industries, all enterprises, all organizations today are undergoing digital transformation. And the idea is basically to have more customized, personalized digital experiences for products and services as consumed by the customers and the end users. So whether it's a telecom company or it's a TV station or it's a government for that matter, or a school, the need to go digital, the need to bring products and services closer to the customer in a way that's convenient, in a way that's oriented to their lifestyle, in a way that's customized and personalized, offers an opportunity for better customer retention, offers an opportunity for larger revenues, and also offers a platform for innovation. So when we look at technologies such as cloud, IoT, big data, AI, and robotics and 5G, all these technologies put together can be thought of as the technologies behind the fourth industrial revolution, which is the new thinking about how organizations and companies will shape the future, will shape their products, will shape their destinies, and will attract higher revenue and compete more favorably in light of the different challenges across the world. Now, a few years ago, Satya Nadella, the CEO of Microsoft, made a very profound statement, and he said, today, each organization must learn how to build its own digital capability, because now every company, software company, every company is a digital organization. So no matter what industry you're in, no matter what sector you're in, the need to be digital, the need to have a digital strategy is inescapable, it's unavoidable. And those companies that have had the leadership and the foresight to transform themselves along their digital capabilities and tap into innovation, tap into the ability to compete, tap into the different advantages of going digital, have allowed those organizations to transition and to become much more relevant to clients and to the economy as they continue to survive in a hyper-competitive and risky environment. Today, we see everybody having some sort of response to the COVID-19 pandemic. And for sure, you note that the companies that are leaders in digital technology are the ones which are having the advantage, as opposed to those who are catching up and are laggards in terms of adopting this kind of strategy. So cloud computing really underpins a lot of the digital transformation thinking for most organizations, and it is a key enabler for whatever transformation initiatives an organization has lined up on its journey to digital. So many enterprises, therefore, are looking at a cloud-first business strategy as they develop software, they develop products as they go to the market, because cloud offers speed, it offers cost benefits, it offers agility. And according to Cisco, by 2020, where we are today, 92% of global data center traffic will come from the cloud. And so the share of data center traffic that's coming from the traditional on-premises infrastructure is shrinking and shrinking as time goes. And the cloud is offering a new opportunity, a new place for organizations to distinguish themselves and to develop products at a speed and the scale that matches opportunities at hand. So from a data perspective, we see that organizations are offering their data across different platforms and locations and user groups. So the idea is that you can have your data consumed by any kind of user, whether it's an employee, a contractor, or a partner. It could be any device, corporate issued, bring your own, employee owned, or even the Internet of Things. And apps could be anywhere. That's to say within your data center, within the cloud, and it could be software as a service, like you can see Office 365 up there. And in terms of geographical location, the location of the end user or the consumer no longer matters. Your staff could be on premises. They could be on VPN, like many of us today. They could be off the network somewhere at home or somewhere in the field, and they still have to consume and access this data. So when we look at the cloud, what would you imagine when somebody talks about cloud? How would you explain it to a non-technical person or a novice? Or maybe if my daughter asked me, what is the cloud about? What is all this cloud thing? So I think this guy was a software engineer, and his child asked him, Daddy, what are clouds made of? And his default answer was that clouds mostly consist of Linux servers, which is largely true. And I believe as we go along, we shall see what kind of underpinning technology makes up the cloud infrastructure as we know it today. So cloud is infrastructure that is shared. It's accessed and addressed on a utility model, meaning that you do not have to put up a cloud data center in order to enjoy cloud services. Pretty much the same way you don't have to build a power station in order to have stable power in your home or your business. So the utility model is very important in terms of the pricing and the ability to be served. It's a pay-as-you-go model, meaning that you pay for what you consume. The resources are elastic and scalable, meaning that capacity can go up and down depending on demand. And one key or very important aspect is that it's programmable and software defined. It's driven by APIs, meaning that the physical infrastructure or the physical tangible components that make up the cloud are controlled using the software model that allows you to abstract and have management or control parameters which do not really have to be tied to the underlying hardware. So you might have whatever kind of infrastructure you have at the back end, but the same APIs, the same calls, the same processes are used to provision storage, to provision security, and to implement whatever other kind of policy that you want. And then obviously, at the end of the day, cloud is important because it is ubiquitous. It's everywhere you go. It is able to scale across global divides, across different regions of the world. And that's what makes cloud attractive for everybody who wants to use it as a platform for their deployments. So looking at the infrastructure or the components of the cloud, at the bottom, you'll follow with me. At the bottom, you have the infrastructure, the compute or the servers, the storage, and the network infrastructure. And then in the middle there, what is being called the platform, you have different services like database, like queues, like runtime environments, identity and access management, and object storage that can be used as a framework for building the higher level applications that you see up there. Could be collaboration, could be content, could be finance, whatever kind of infrastructure you want can be built upon the cloud. So the foundation really comes from the compute, the storage, and the network infrastructure, and you can consume and provision cloud services basing on that, and you can take it to platform and application level or even beyond the application level. So cloud has three key service models that allow it to be consumed and used by the end users. The first is infrastructure as a service, which is the most basic layer. It provides customers with access to the virtual servers and the storage that they need to load their operating systems and load their software and load their data. Then the next level is platform as a service, where you have a vendor who has done the hard work of maintaining the back-end software, operating systems and storage and any other infrastructure, and developers or users come to build on top of that, build their applications on top of an existing platform that's provided and run by a vendor who is experienced and highly specialized in that. And then at the top end, which is our bottom end here, is the software as a service, which is basically where you consume the final software. Could be email, could be CRM in the example of Salesforce. It could be any software where you simply consume on a basis of licenses or named users or storage that you make use of in the case of something like Dropbox. So the complicated part of the application and the software and the operating systems and the servers is left to the vendor, and the consumption model is basically pay as you go or for what you have used. Now, cloud vendors or cloud service providers, to be more specific, include, number one is Amazon, who is the leader or the most experienced and the most widespread in this market, followed by Microsoft Azure Cloud. Google also has the Google Cloud Platform. And then we also have to recognize people like Alibaba and Huawei, who are representing the China, Southeast Asia demand side of things. Because of the geopolitical tensions around the world, China has decided to pursue its own global cloud infrastructure through Alibaba and the likes of Huawei. And they're basically looking at the untapped market of Southeast Asia, which is high growth, and also markets like Sub-Saharan Africa, which represent the next frontier of growth. So you'll also notice that there's Openstack. Openstack is primarily used for internal cloud operations, private clouds, where the typical customer would be like a telecom company. Telecom companies are now deploying 4G and now the 5G networks basing on an internal private cloud model where the different network elements are provisioned in a cloud architecture, and that allows them to have the efficiency and the ability to meet the scale that comes with 4G and 5G kind of network services. So in terms of success stories that you could cite for cloud services, out of Africa and specifically out of Uganda, we have SafeBorder, which is an innovative transport platform. SafeBorder is active in Uganda. It's active in Nairobi, Kenya, and recently it launched in Nigeria, in one of the cities outside Lagos. I think at the time of they were going into the market, the regulator issued a ban on safe borders or on border borders or Okadas in Lagos, and so they had to go to one of the second or third cities within that country. But their application is based on a cloud infrastructure, and that allows them to enjoy the benefits of scale, the benefits of being able to be present in different markets. They choose a market and don't worry about the infrastructure because the cloud service provider is able to scale up and meet them where they are. Another key example we can cite is Jumia, who have a Pan-African approach to e-commerce and transforming the way Africans live, work, and shop. So you've seen a lot of Jumia promotions, Jumia market penetration within Uganda, and their story is cloud-based. They've been able to deploy the infrastructure across Africa and leverage the power of the cloud to enjoy presence and ability to satisfy customer needs. Then we have obviously veterans of the cloud like Netflix, who have redefined the cloud and made it a profitable place. Netflix runs, I think, the biggest client for Amazon AWS, and they're able to scale up demand dynamically. For example, Netflix will be able to give you the service that you want if everybody is logging on in the evening and they're back home to watch their favorite shows. They're able to scale up and meet that demand without having to invest in the infrastructure upfront. And now in this COVID 2019 season, you have champions like Zoom who are coming to the market, and they're being relevant because they have cloud infrastructure which they can leverage to meet the needs of working from home and any other remote work needs that we are seeing in this COVID 2019 situation. So the ability to go to the market, the ability to scale faster, the ability to go into a certain sector without having to have upfront capital expenditure on network and computer infrastructure is what makes the cloud a success. And that's why you see all these common or famous companies leveraging that set of advantages to be in the market and to thrive. So bringing it closer to home, maybe we have in Uganda, NITAU runs an e-government cloud. You see some people you might recognize down in the picture there. That was at launch last year. We also have existing content distribution networks in Kampala for internet companies like Google, Facebook, who use those facilities to make their content more accessible and more responsive for the consumers who are based in Uganda. Then we have an organization called RENU, Research and Education Networks of Uganda, which runs an academic and research community cloud for universities and tertiary institutions. And that really makes cloud relevant in the sense of what's going on in the cloud space within Uganda and how are organizations and companies making use of it to achieve their business objectives. Across the border, recently, President Uhuru met with Amazon and was able to flag them off. They've launched an edge location in Nairobi for their CloudFront content distribution network, which means that if your content is hosted on Amazon, you can have faster access and you can have better response times for your clients within East Africa because of that presence in Nairobi. And they've hit off a reseller partnership with Safaricom. And down south in South Africa, we have Amazon, Microsoft, and Huawei public cloud regions active in South Africa since 2019, meaning that the continent is getting more and more cloud infrastructure simply because sub-Saharan Africa is one of the fastest growing regions of the world in terms of population, and demand for internet services is going to grow accordingly. So the investments and the infrastructure that needs to be done, you will see more and more of it happening in light of this kind of prospects. So coming down to cloud, what exactly it is, you typically have virtualization of computer hardware being the foundation for cloud. You take a physical server and load software on it called a hypervisor, which allows you to run multiple virtual machines or VMs on top of that host operating system or host server. So you have those guest operating systems running, and each one is running a different app or different instances of the same app. And that basically forms the foundation of your cloud computing. So you have thousands and thousands of servers running millions and millions of virtual machines. Now, that can be extended to the container model where you have a host operating system without exactly running a hypervisor, but having shared files, shared binaries and libraries, and those are used by different applications or instances of the same application to allow you the scale to serve customers and to react to demand basing on the time of day or what the customers are doing. So the kind of technology you might see on the container side might include Docker, Swarm, or Kubernetes, while on the VM side, traditional VM side, are things like VMware and KVM or Microsoft Hyper-V or any other hypervisor software you might look at. So cloud infrastructure is built physically in terms of data centers. You take up a data center and build your infrastructure from the servers to the storage to the network infrastructure, and then all the other facilities that are required to make a reliable data center happen, like power and cooling. And then in a region like if you took Africa as a region, you'd have multiple data centers located in terms of availability zones. meaning that an availability zone is a place you can deploy an application and you have the assurance that it is separate from the other infrastructure in that region. And if you wanted to have a stable application or a highly available application, which is fault tolerant, then you might deploy it across multiple availability zones. So today in Africa, we have a single availability zone in South Africa. We have one in Johannesburg and one, that makes two. One availability zone in Johannesburg and one in Cape Town, South Africa. And you can deploy apps in those. The next availability zones could be in the UAE or in Europe, depending on which vendor you're looking at. And that now allows the vendor to spread across multiple regions, multiple continents, multiple countries, and offer services as close as possible to end users, and giving you options to also be compliant with legislation like privacy, which might require you to have your data hosted within a certain geographical region without leaving the country. So in this example of a cloud computing application, we have an on-premises Active Directory setup, and it's connected to the Microsoft Azure cloud. There's an Active Directory instance running in the cloud, and that is also connected to an SQL Server instance, an SAP instance, and some virtual machines and things like Office 365, Google, and other apps within the cloud. And then on this other side, you have a client application accessing that infrastructure or that application, the server application across the cloud. And you basically have, in this scenario, a hybrid cloud where you have some of your infrastructure on premises and other infrastructure in the cloud, and you're able to support different business needs according to whatever the business requires. In this example, we have something a bit more detailed, but this is Amazon AWS, where you are depicting two availability zones. You might say one is in Europe, availability zone one is in Europe, and another one is in Cape Town for the sake of it. And together, those two availability zones form your virtual private cloud, the VPC. And in that virtual private cloud, you can deploy different instances of server resources. And in this case, we have an auto-scaling group, meaning that the infrastructure can react to demand. It can react to increased or decreased demand and scale up the resources. For example, if right now people are going home and they are going to switch on their TVs and start watching Netflix, then your service, which is based on Amazon auto-scaling group, will scale up to meet the demand, and will go back to normal levels when the demand passes. You could look at the self-border option. You could look at different applications which have different demand patterns or demand curves, depending on the time of day. So that concludes our part one, cloud computing overview. I'm not sure if we have any questions or if we can take questions now, but I think I'll proceed. We shall proceed and we should look at risks and security issues around the cloud environment. So in terms of risk thinking or risk management in the cloud, you can sum it up and say the problem with the cloud is the cloud itself. The whole idea of cloud simply turns the security thinking upside down, because things that you were previously able to do within the comfort or the privacy of your own premises data center are now being done in the cloud in a public environment. So mistakes or oversights or misconfigurations which were common and had limited impact in a on-premises data center scenario are now having catastrophic impact when replicated in a cloud environment. So majority of the cloud breaches or data breaches that you see today are simply because the businesses or the system administrators or whoever is in charge of deploying cloud applications are repeating the mistakes or carrying over the weaknesses that they've been able to survive or live with in an on-premises environment, they're taking those to the cloud, and the catastrophic impact is out there for everybody to see. So cloud basically requires us to have a paradigm shift in the way we approach security and risk management for applications and data deployed in the cloud. Now, the paradigm shift is important because the whole idea of a perimeter is no longer there. You no longer have an internal part of the network and an external part of the network with the good guys inside and the bad guys outside, and in between you put a firewall of your choice and you watch to see who tries to get in. Today, the cloud simply means data is available to everybody anywhere all the time, whether they are within your network, outside on the street, roaming users, in the branch. Everybody needs access to this data all the time, and you cannot track it the same way you tracked it in an on-premises world. So the whole idea of the who and the where changes, and we now have to address cloud security pretty much differently because the picture has changed, and the challenge is on us to think differently and approach the security program differently. So cloud itself is simple because it offers the benefits, it offers the speed and the agility, but cloud security is more complex because then you now have to redo things and rethink things that you were taking for granted or you had found solutions for 20, 30 years ago. The different security models which had been developed 20, 30 years ago are no longer able to serve us in a world where you have big and fast data with virtualization and then expanded attack surface, an application architecture which involves continuous development, meaning that you're pushing code every day or every hour, and sometimes it's automated, sometimes it's not done by humans. You're in a world of APIs, everybody's interconnected to mobile money, to the government, to tax payments, to whatever you want to think of. It could be farming data, it could be statistics, it could be real-time location services, it could be healthcare data. There's a lot of interconnection and APIs, and application architecture just gets more and more complicated each day. And you have the hybrid cloud on the other side where data exists on premises. Some of it is in a Microsoft cloud. Other data could be in an Amazon cloud, and other data could be in whatever location you could think of. Data exists across so many places, and you have to be able to account for that data and protect it wherever it is while making it available without constraining the business. So organizations will now look at things like malware and ransomware hitting them from all sides. They look at the compromised accounts and malicious insiders who are able to take charge of the data and the resources and maybe breach or leak this data and cause uproar in the public and privacy legislation to bite the companies that have been in breach. You have gaps in visibility and coverage. Many people are unable to account for their data, even in an on-premises environment. When it comes to cloud, the story is different because you now have no idea where your data exists and how it got there, and it becomes a nightmare for whoever is in charge of this. And so the thinking and the approach must be different. So I want us to look at the Cloud Security Alliance top 11 threats for 2019. And just to give us a picture of what's going on in the cloud space and what are the top issues that are there to look out for, and that will kind of shape our approach to the controls in terms of the architecture, the thinking, and then the actual controls that we shall put in place or we shall identify. So the biggest threat on this list is data breaches. For any organization that is in the cloud, they have to fear data breaches, number one, because that is the ultimate scenario, the worst case scenario that you have. Your data will be breached, it will be leaked, it will be stolen, it will be exposed in ways that embarrass you, in ways that hurt you, in ways that expose you to regulatory action. in ways that cause the public to walk away and move to competition because they have lost faith in your ability to serve them and secure the data. So data breaches constitute the biggest threat for most organizations. Then second, we have misconfiguration and inadequate change control. For the complex infrastructure and assets in the cloud, it's important to have the right level of configuration, otherwise that leads to exposures. Many organizations thirdly lack cloud security architecture and strategy. They are approaching cloud security in an operational way, in a best effort way. They have not sat down to recognize the key issues that must be addressed in order for you to succeed as a business that's operating in the cloud. Number 4 is attributed to insufficient identity, credential, access, and key management. This is basically about authentication, authorization, and accountability of the users and identities that have access to your cloud resources. Number 5 is account hijacking. Number 6, insider threat. We all can recognize that threat. Number 7 is secure interfaces and APIs, where services and interconnectivity is deployed or are made available without thinking about the security exposure or the risks that comes with. So a lot of organizations are deploying cloud services or are connecting to one another in the cloud over the internet, and are not taking the time to do security assessments of what that interconnectivity or what those APIs further expose the organization to, on top of getting the job of interconnectivity done. So number 8 is the weak control plane, simply meaning that an attacker can take charge or can compromise the control plane or the management interfaces, the management area of the cloud services, and use it for their benefit. Metastructure and appli structure failures simply are to do with architecture. How are cloud services architected and designed, and how does that tie into their ability to serve under stress and under strain? Limited cloud usage visibility. Many organizations have no idea how much of their applications and how many of their staff and partners are using the cloud to process the data that they are in charge of. And then number 11 is the abuse and nefarious use of cloud services, where criminals and nation states or anybody else who is into cloud, using cloud for crime and other illegal activities, are making use of that and using it as a new platform or a new frontier for doing their trade. So having looked at that, I want us to take a look at one of the noteworthy examples from last year, which demonstrates the kind of risk and kind of impact you can have from a cloud breach. Capital One Financial Corporation is an American financial services company, and they basically do credit card business. Now, in March 2019, a young lady, 33 years old, a former employee of Amazon, was scanning the internet for misconfigured cloud instances, and she came upon an Capital One cloud instance, a server on AWS, which had a vulnerability. So she exploited that vulnerability and was able to leak 106 million client records. Most of these were for people who had applied for a credit card at one point in time, stretching back maybe 20 years prior to that. And in leaking that, she also was found to be running a crypto jacking operation, basically where you mine cryptocurrency using a victim's server. You take over somebody's server with malware or with whatever software you have, and use those resources to mine your cryptocurrency. And in this case, since it's cloud services, the bill goes to the victim and the cryptocurrency goes to the attacker. So in a strange twist of fate, hard to understand, after doing all this, she posted these details of what she had done on GitHub, which is a site where you can share code, and it's used as a repository for code for many developers across the world. She shared the details on GitHub, and somebody alerted the FBI in July 2019. So when it comes down to it, the essential things that happen are: one, Capital One had a misconfigured web application firewall. They had put a web application firewall on one of their servers, that is Apache mod security. And this was exploited using a vulnerability or an attack called server-side request forgery. And then the server was used to access a private or something that's inaccessible from the outside world, which runs on every Amazon web server, every Amazon compute instance. It's called the EC2 metadata service. So if you access this service, you're able to read sensitive credential information, and you're able to make use of that to connect. So it's basically like going to a company and you stop at the reception, and maybe somehow you convince the receptionist to give you the Wi-Fi key for the company's Wi-Fi. And when she gives it to you, then you can go and maybe sit in the parking lot and connect and have access to everything within the organization, because you simply exploited the weakness at the reception or at the front desk. So the idea is that this misconfigured web application firewall was able to read private data and hand it to the attacker using this server-side request forgery technique or attack. So having got the AWS keys for Capital One, she was able to connect using her own machine and gain access to storage buckets or storage instances or files that were in 700 different buckets. And she copied those to her own other storage buckets on the internet. And nobody has an idea of how many times those were downloaded, who downloaded them. Was it the Chinese? Was this the Russians? Was it whichever kind of attacker or threat agent you might have on the internet could have access to those records and could be going to use them for whatever they want to do. So Capital One, incidentally, is a very wealthy organization. They have a lot of high-end security, but this represented one of the failures where you have assets or infrastructure on the internet which you can't account for in terms of its security or in terms of its risk exposure, and that is used to get into the heart of the organization. Just one server out of the hundreds or the thousands of servers that Capital One has, it was used to access all these 106 million client records. And this now has a negative impact on the organization in terms of regulatory action, in terms of their stock price went down, in terms of lawsuits that they had to endure, but also in terms of organizations that are looking to go to the cloud in terms of financial services. They start to think twice and look at the risks, and it becomes a longer wait for those benefits of the cloud. So having seen that, I recommend that we do not have the time to go into this, but I recommend the attack matrix, which is maintained by the MITA Corporation. Please, when you get to slides, please take time to look at that site and look at the different, how a cybersecurity attack can progress in a cloud environment using the different threat vectors or the different points of entry. And it will enrich your understanding of the points of weakness, the vulnerabilities, and where to focus in terms of controls and assessment of those controls. Now we shall look at cloud security models, which give us an appreciation of the thinking behind security in the cloud and how security in the cloud should be done to overcome the challenges that we've seen and the other issues that have been highlighted over the years and have made cloud computing risky, we want to look at how to approach cloud security differently. So in terms of cloud, I would maybe highlight 3 objectives in terms of security objectives. Number one, for an organization, you want to have visibility to see what your cloud footprint looks like, to see your infrastructure, your data, your activities, your processes that are in the cloud, wherever they are, and to be able to account for them. Secondly, an objective of segmentation, basically reducing the attack surface, having the ability to control what is exposed and what's not exposed within your risk management criteria. And then thirdly, threat protection, being able to address breaches before they occur, and even when they occur, being able to mitigate the impact and have a cybersecurity resilience capability that is effective. Because today, threats will come, breaches will come. It's a matter of when and not if. And so organizations must think across the whole life cycle of preparation, defense, and recovery from an attack, and being able to mitigate the impact on the organization when that attack occurs. So the primary or the foundational thinking behind cloud security is the shared responsibility model, and it essentially aims to define responsibility between the cloud service provider and the customer in terms of who has a role to play in what area, and that allows you to have a governance approach that then determines how the rest of the activities go. So across different infrastructure models or cloud delivery, cloud service models, you have different responsibility. Now, on the left, on the on-premises scenario, as a customer, you're responsible for all the infrastructure, starting from the network, compute, application, data, and the user, because that's on premises. In a software as a service scenario, the cloud service provider is responsible for network, compute, and application, and the end user or the customer is responsible for the data and how the users or the identities or the accounts are provisioned. Now, in a infrastructure as a service or platform as a service scenario, the delineation between the cloud service provider and the customer is somewhere at the application level, and it depends on what the cloud service provider is offering, the nature of the platform. It could be a database platform, it could be a big data platform, it could be an Active Directory platform. But the idea is that there must be focus on what the responsibilities are so that there are no gray areas and the governance is clear on who has what responsibility, and that therefore determines the actions or the processes that follow on that. So it's important to have the cloud shared responsibility model documented and agreed upon and understood before you get into a cloud arrangement or cloud computing contract, so that there is clarity on who's responsible for what, and then whatever assurance can be done or can be undertaken on the basis of that. So this is an example of Amazon Web Services where they delineate it a bit more. So according to AWS, these 2 categories on the left, there's the customer and AWS. They say the customer is responsible for security in the cloud, while AWS is responsible for security of the cloud. So AWS will secure your regions, availability zones, and edge locations, the hardware and the global infrastructure, the networking, database, storage, and software. Those are the software components. And then depending on what you're consuming as a customer, you obviously have to secure your data. You'll have to secure your platforms, applications, identity, and access management. you might have to secure your operating system, networks, and file configuration, and then server-side encryption, network traffic protection like encryption, integrity, and identity, and all these other security requirements of data as it transitions the network, as it is processed, and as it is stored. So there's a lot of security guidance and a lot of recommended controls and a lot of automated tools that are available to be used. And it's important to be able to go beyond just consuming the service, but have an understanding of the risks and be able to secure the services and the data appropriately. Now, the security in a cloud environment is an ongoing process. You must be secure every day. And so it's not a one-off kind of thing which you do once in a year or once in 6 months. Security must be automated and orchestrated to ensure that the policy is implemented all the time and any deviations are captured and they are notified to the right people accordingly within real time to mitigate breaches. So the second security model that we'd like to look at today is the zero trust model. And the idea behind zero trust is that you must assume a breach and you must verify each request as though it originates from an uncontrolled network. So the same security you apply when you're on the internet, the same security you apply when you're outside your house or outside or in the middle of Kampala Road is the same security you apply when you are inside your data center or inside one of your most personal or private spaces. So the idea of trusting data or trusting people depending on where they come from, trusting connections or requests depending on where they come from, is a security weakness. So all requests must be subjected to the same stringent verification mechanisms regardless of where they come from. So the idea is never trust, but always verify. Every access request is strongly authenticated. And by strongly means that you have multiple factors. You're not just using maybe username and password or an API key. You are adding additional criteria to that. Then authorized within policy constraints and inspected for anomalies before granting access. So that is a robust authentication and authorization process. Then the other factor is applying microsegmentation and least privilege access principles to minimize lateral movement so that if access has been granted, that access cannot be used to gain further unauthorized access within the data center or within the infrastructure estate. And then having the ability to use rich intelligence and analytics to identify what happened, what was compromised, and how to prevent it from happening again. So this is the intelligence side, the threat intelligence, and being able to understand your environment continuously so that you're able to build a baseline and you're also able to arrest and mitigate issues before or as they occur. So some additional principles: verify explicitly, authorize and authenticate based on multiple data points, including user identity, location, the device health, the service or workload in question, data classification, and any anomalies. Then use least privilege access, just-in-time access, or just enough access, risk-based adaptive, and data protection to protect both data and productivity. And then assume a breach because at any one time, do not assume that you are so safe or you are not compromised. It's important to have the assumption that the environment is compromised and you must be able to protect yourself even when you are in a seemingly safe space. So minimize blast radius for breaches. If one server is breached, don't let that breach seep over or spill over to another part of the network. We see this commonly in ransomware scenarios where one computer is breached and that progresses to the server and the backup and any other attached infrastructure, simply meaning that the blast radius of that incident has been so wide. So minimizing lateral movement by segmenting your network, your users and applications to ensure that everything is compartmentalized. And then all sessions are encrypted end to end so that there's no ability to compromise data, whether it's inside the network or outside the network, and having having your analytics to give you visibility into what's going on and improve your defense. So in a zero trust environment, controls must be implemented across 6 elements: your identities, which could be end users, machines, or workloads; the devices that are used to access this data or these processes, could be servers, could be IoT, could be workstations, laptops, smartphones, etc. The applications that you want to secure, the data that you ultimately want to secure most. Organizations, or most people, will focus on the data because that's the ultimate prize. But the other 5 elements of infrastructure, networks, identities, devices, and applications are also critical to be covered in order for you to have security that is sufficient. So in this scenario, in this picture, you'll see on the left side, we have the identities and devices, which form the active agents that need access and are subject to the policy enforcement before they gain access to whatever assets are on the right side. So up there on the right side, you have your data, which must be protected, and then the apps that must also be protected in terms of who has access to them. Your infrastructure, it could be cloud or containers or platform as a service, and then the networks that are used to deliver the data to whoever needs it must also be protected. So the idea is to have accountability, risk assessment, and protection across these 6 elements. And across the entire spectrum, you need to have visibility and analytics. And then your operations need to be automated, meaning that you shouldn't wash your own clothes. If you have a washing machine, you might have a better use for your time than washing clothes manually. So doing security manually does not work. There must be automation in terms of your information security capabilities. Otherwise, in a cloud environment with hundreds and thousands of events per hour, just cannot be done using manual methods, or you cannot wait for the end of the year or after 2 years when you have a budget for pen tester or a security assessor to come and do the assessment for you. You might not be in business by that time. So it's important to have real-time, automated, and orchestrated policy enforcement and feedback and threat intelligence from your environment. We cannot really overstress this or understress it because that's a reality. You cannot do security manually. You cannot do security through pen tests or through periodic audits. In an environment like this, you just have to deliver security using orchestration and automation. Okay, so as we preach mindset change for zero trust, do not forget that location does not amount to trust. Don't grant access to data based on where the requests originate from. Trust erodes when you have authenticated a request. It must expire. That authorization or that authentication must expire quickly because the situation could have changed. A trusted agent could be compromised within a very short time, and they could leverage the authentication they have to gain access, which is unauthorized. Access must be restricted, so you do least privilege, you grant access for a short time, and then you also keep understanding the environment, the way it's changing, and apply risk-aware approach to ensure that you do not compromise your data. Then finally, as always, policy must be automated. You automate the policy, and then you also automate your ability to collect feedback on those controls, how strong they are and how effective they are. Emily, do you have any questions at the moment?
Yes, Bernard, we do have some questions.
Do you want me to take them now?
Yeah, I think we can just answer I have about 4 questions. We can do maybe 2, then another 2, and the others at the end.
All right.
So the first, okay, thank you, Bernard. The first question is from Edward, who is asking that in your view, do you see the regulators of sub-Saharan Africa opening up to allow their financial institutions to store customers' critical data in the cloud in the near future? That's the question we have from Edward.
Mm-hmm.
Then another one is from Geoffrey, who is asking to what extent can a financial institution in Uganda adapt cloud solutions given the regulatory environment?
Okay, so I think in terms of cloud, thank you, Emily. In terms of cloud, change is coming. The speed of change or the rate of change is going to be fast. Today we have, for example, a government cloud, private cloud. NITA runs a government cloud. So cloud does not really mean that you have to put things on Amazon in South Africa or Amazon in Europe. I am confident that within the next 5 years, we shall see Amazon regions within East Africa or even Uganda itself. We have a data center being built by Raxio. We have data centers by MTN and Airtel. And as demand goes up and as the business case improves, so we shall have availability of in-country cloud data centers, and we can then have a conversation which satisfies the regulatory requirements of data staying within the territorial boundaries of Uganda. So that is changing fast. Today, you may not have many choices. You might have 2 or 3, but in maybe the next 5 years, cloud will become part of the way we do all kinds of business, regardless of regulation. I'll give you an example. In America, the US government mandated Amazon to build a government-only cloud. So they have AWS for government. So the US government is using AWS, but it's customized for government to meet government's regulatory requirements, and they've been able to successfully deploy that, and it's now shaping the way government does business or the way government operates in America. So that is going to change. Emily, please read from the second question. I cannot remember it clearly now.
No, it's all right. Thanks, Bernard, for answering that. So our second question was from Geoffrey Nkutu, who is asking to what extent can financial institutions in Uganda adapt cloud solutions given the regulatory environment? Then he also goes ahead to ask if any of the financial institutions in the developed world made use of the cloud solutions for storage and hosting of their DBs of critical systems.
Yeah, I think in Uganda, it's still a question of the regulator moving slowly. I think the regulator will move faster as the assurance becomes more clear and as they understand the benefits and the needs. So infrastructure is going to land and it's going to become easier to satisfy regulatory requirements. And the regulator will also start to bend more and more because the reality is such that cloud is inescapable. In terms of who has deployed, I know somebody in Uganda, microfinance, which has deployed on AWS. In the developed world, we've just talked about Capital One. Capital One was a key part of the financial services space. They deployed to the cloud, and that's how they were hacked. I know that one of the top fintechs in the UK is runs on cloud services. So a lot of a lot of organizations which are in highly regulated industries are able to run on the cloud because the cloud is in the developed world is able to satisfy the regulatory requirements, especially the territorial boundaries. So, for example, Office 365 in Germany runs infrastructure specifically in Germany because German laws require German data not to leave the territorial boundaries. So they have a specific cloud built in Germany just for their German clients. So as investments and as time moves, we shall see more and more of the things becoming a reality. Okay, so I'd like to move on to controls. And we want to look at some ideal approaches to implementing the controls that we've been talking about. So I always start with this slide, which really sets the stage in terms of separating governance from management. It's important to have a governance approach, which then drives the management activities. Governance gives you the mandate to execute, to create change, and to drive improvement. And management is now about the people, processes, and technology that you require to implement and execute. So from the management side, in terms of from the governance side, there must be commitment to change. There must be commitment to cloud risk and cloud security management. There must be strategic alignment to ensure that any cloud initiative, any cloud computing agenda is aligned with the organizational strategic objectives and it is able to support the organization's strategic objectives. And then the risk management part in terms of what we've just mentioned, the compliance and regulatory side of things, then the risk appetite in terms of what the board or what the stakeholders feel, and any other concerns like privacy legislation and data protection must be taken care of at this stage so that there are no surprises and there are no showstoppers when the cloud implementation starts and when things start to become a bit heated. So having set the stage at the governance level, then management is mandated to implement controls, and basically those controls will be in line with the strategic objectives and the risk management criteria that has been set by the governance level. And you typically want to have more preventive controls. I don't know if this pie chart comes out well, but the preventive controls should be your majority because they are more efficient. It is cheaper to spend money in prevention than to respond to lawsuits or to pay regulatory fines. So preventive and detective controls must constitute the majority of your control environment. And then controls to respond are very important because the reality is such that all organizations at one point in time will face a cyber attack. It's a matter of when and not if. And so the organization must be prepared to respond to the attack on the basis of its understanding of its exposure and what capacity it has to make a meaningful response. And then on the other side of management, you must have continuous improvement in terms of your ability to perfect your processes. You must have automation and orchestration as a foundation for your controls. There must be an environment which is automated. And then there must be feedback of those metrics to the governance level to ensure that management is aware of what is going on and it's able to support and is able to align resources to ensure that the right things are being taken care of in terms of your information security program. So when it comes to implementing these controls, we normally have to start with the frameworks because the framework gives you an easy way to get started without having to reinvent the wheel. Most frameworks have recommendations that can be practically applied. Now, the key frameworks you might want to consider in a cloud environment are the Cloud Security Alliance, who published the Cloud Controls Matrix, which is a comprehensive collection of controls across different vendors, different organizations, different regulators, and they link it together and give you 13 domains which should be looked at and should be implemented. Then we have the ISO 27000 and 31000, which everybody is, I think, familiar with. We have our COVID 2019 from ISACA. Then we have the CIS Top 20 Security Controls, which are basically cyber hygiene, cyber defense, cyber hygiene. And then PCI DSS, which applies to those who operate financial services, cardholder processing facilities. Now, those controls should be evaluated, should be selected to meet, to find which ones meet the organization's needs. And then from there, you can move on to actually implement. So I want to look at the Cloud Controls Matrix for a moment and just share what value it might have for you in your environment. So the Cloud Security Alliance produces what they call the Cloud Controls Matrix, and it's a controls framework with the detailed understanding of security concepts and principles in 13 domains. It offers a customized relationship with other industry accepted standards. So it picks controls and regulations and links them to ISO 27000, ISACA, COBIT, PCI, the NIST in the US, Jericho Forum, NAC CIP, the AICPA, and so many others, so that your internal control direction is shaped by the best practices and recommendations from those organizations. So the link to that Cloud Controls Matrix is down at the bottom. Please visit the site and download. It's an Excel spreadsheet, and it has additional artifacts that allow you to score your current control environment and form some sort of gap analysis that allows you to implement relevant controls based on the information you'd have given. So when we look at the top 11 threats for cloud computing, number one was data breaches. And I wanted to just position the different controls that are recommended by the Cloud Controls Matrix to address data breaches, just to give you a picture of what is involved in the Cloud Controls Matrix. So you have a class like application and interface security. Another class is change control and config management, data security and information lifecycle management. And under these classes, you have different controls that are required, and those controls can be broken down to specific guidance that should be implemented or should be considered for implementation to give you better assurance in your environment. So as we move to close, the key controls I'd like to mention and recap. Number one is governance. Governance is important because it allows us to have the vision, to have a sense of direction, to have management support, and also to have the resources and accountability required to drive a security agenda. Then the second key control that must be considered is the security architecture. Having a deliberate design and implementation guidance that determines how things are done allows us to have more control over the outcomes in terms of risk. So implementing an architecture like Zero Trust allows us to have a more robust infrastructure, a more robust set of controls, more robust risk management that can stand up to the threats and issues that have to be faced in a cloud environment. And then coming down to a more operational level or a class of controls is identity and access management. It's important to account for whatever access there is to your data, to your platforms, your network, to your assets in the cloud environment. And this is typically done through the identity and access management. If your keys or your passwords or your credentials can be stolen or can be compromised, then it's a kind of game over scenario. So when implementing identity and access management, please remember to have multi-factor authentication, and not just for the high risk or those perceived to be high risk accounts or high risk users. It's important to have multi-factor authentication everywhere. Having multi-factor authentication in a few places is not enough. I normally have this example of you have maybe a VIP who has a bodyguard moving with him or her everywhere they go, but they may not have a bodyguard for their wife or their children. So if you want to target the VIP, you can target them through their wife or their children simply because they have not gone ahead to have extra security for the people who are close to them. So having multi-factor authentication must be done across the board to ensure that you have essentially covered all the bases. Multi-factor authentication in a few places alone is not enough. It has been proven to be insufficient. So do not make the mistake, do not live in that sense of false security. There must be multi-factor authentication everywhere to secure your access credentials. And then we've been repeating the policy automation and orchestration. Basically, your policy should be able to roll out automatically, or through a service should be programmable so that all elements are able to receive this policy and are able to accept it. And you're also able to do assurance by querying or examining or assessing these elements in your network or in your infrastructure for the presence or the strength or the implementation of this policy. And that creates an automated and orchestrated security environment. So some key elements you might have in your policy automation and orchestration include the Cloud Access Security Broker, or the CASB. The CASB is basically a firewall or a security appliance which secures your users as they access a cloud service. So for example, you might deploy a firewall which has a CASB module, and when your users want to access maybe Office 365, they have to go through this firewall, and it will ensure that the policy requirements that you have set for access to Office 365 are upheld, so that even if a user is targeted or is compromised, that compromise will be detected and will be mitigated at the level of the firewall before the user has access to the cloud service. So having such an element which can implement or enforce your security policy within your cloud environment is very important, and it's a practical example of automation and orchestration. Then the vulnerability assessment and penetration testing, that is obvious, you need to have it, just that maybe nobody may have the budget to do it every 6 months or every 1 year in terms of pen tests, but vulnerability assessment should be done almost on a daily basis, because that can be automated, that can be acquired as a software as a service model, and it's pretty much very, very affordable and very common, especially for the key assets. Then footprinting is basically trying to account for what you have where, trying to look for your data in different places, hopefully before the bad guys find it, because many organizations will have, for example, Dropbox or many other consumer type cloud services hosting their data without them knowing. So it's important to be able to try and account for where is your data going, who is keeping company data or organization data on personal or private Dropbox or any other kind of storage services, which might cause you a risk which you did not foresee or you had no idea of. And then awareness, empowering your users with information and the ability to make the right decisions, because they are at the front line. You might have all the governance architecture and security tools in place, but if your users make a wrong decision of clicking on a link or opening an attachment in a phishing email, then it's a game over scenario. You do not really expect any much salvation after that. So it's important that end users and executives and administrators have the right training and awareness to be able to handle security risks and issues consistently. Okay, so as we close, this is my last slide, I promise. Cloud computing is a pillar for digital transformation, meaning that it's going to be more and more prevalent. It's going to take over. It's going to become part of life. We cannot run away from it. In cloud, the security paradigm is different. We must think differently about security in the cloud. We cannot think in a traditional on-premises sense. We need to have intelligence, automation, and orchestration of our security functions. We cannot do security manually. Identity and access management are key to cloud security. At the end of the day, you must always protect your credentials because that's what determines who has access to what. The data is no longer within your control in your premises. It's out there, and the only key to it or the only determinant of who has access is the credentials that have been set. So if those credentials are compromised or they are lost, then the game is over. Threats and threat actors will continue to evolve rapidly. So you have insiders, you have disgruntled staff, you have nation state actors, you have ransomware criminals and things like that. So it's important to understand how the threat environment is changing. A threat that was prevalent 2 years ago may no longer be prevalent, or one which went out of business a few years ago could be back with a bang today. And finally, as information security and risk professionals, we need cloud skills. We cannot continue to operate at a level of hands-off. We must be able to understand what the cloud means. We must be able to leverage cloud. We must be able to make use of automation and orchestration of security functions so that cloud can benefit from our expertise. Cloud can have the same protection as other parts of the infrastructure, and it can continue to serve the business sustainably. So thank you so much. That is all from me today. Do we have any questions, Emily?
Yes. Wow, thank you so much, Bernard, for a very good presentation. It was very insightful. I guess everyone that has attended will agree with me. We have 3 questions so far, but I think I'll read the first 2. Then after we've answered that, then I'll go through the other ones that will come through. So our 3rd question is from Catherine Niwagaba, who is asking that if I need cloud service, say IaaS for mid-sized business in Uganda, where would I go and how would I secure it? Then another question is from James, who is still thanking you for the very insightful presentation and is asking that in the Uganda context, is there a legal framework where companies that have servers with servers that have been hosted there, and are the standards as of now, for cloud hosts? Bernard.
Okay. Catherine, thank you for your question. Today, infrastructure as a service or cloud services there are many vendors. You have people like MTN Business. In a few months, we shall have Praxio Data Center. They're building a data center in Namamve, and they offer hosting services. We have other vendors who represent the likes of Microsoft and Amazon and Google. Those are easy to find. So there is no shortage of options. Maybe all I can say, and as I've been saying, as time goes by, the situation will get better and better in terms of the options that you have, the costs will go down, the ability to host your data locally will also improve, the ability to use the same technology and the same models and the same tools. For example, having Amazon in country is going to happen soon. So there's a lot of options and you don't have to worry so much about what is available, just that the quality the quality is going to get better and better as time goes. I did not hear James's question properly, if you don't mind.
Okay, I'll just repeat that. So James was asking that in the Uganda context, is there a legal framework companies that have servers hosted here? I don't get that. I think he's asking if there's a legal framework for the companies that have servers hosted here.
Okay, I think when you talk about the legal framework, my mind goes to the Data Protection Act that came into force last year, and it has a number of provisions. I don't want to sound like a lawyer because I'm not a lawyer, but the idea is that if a company is operating in Uganda, it has to be in compliance with the Data Protection Act, which I think most organizations are, and those which are not, the consequences and the remedies are clear. So we have service providers in Uganda, and we have a law which governs their operations. And I think between the service providers and the law, there is freedom to our clients or consumers to enjoy the service. I don't think the law is very restrictive. It just has the same standard requirements like consent, like transparency, like requirement to have data domiciled or housed within the territorial boundaries of Uganda, and any externalization might require permission from especially the data owner or the subject of that data. So the requirements are basically straightforward, and the vendors that we have are able to obey or comply with the requirements of the law. So I don't think there's a problem. But it's always important to, if you're operating in a highly regulated industry like banking, like healthcare, like insurance, it's important to have the blessing or the go-ahead from the regulator, because you don't want to find out from the regulator that you're doing something wrong, yet the assumption was that it was right. So work in consultation with the regulator if you have a highly regulated industry.
Thanks, Bernard. We do have, Bernard, we do have the question from Andrew. Bernard?
Yes, I am listening.
Yes. Oh, okay. Yeah, we do have a question from Andrew, who is saying cybersecurity monitoring is known to be automated based on the set policies and controls. So he's asking that what learning points do you have for using tools that have been automated for end-to-end access, authorization, modification, and termination, especially as this would be key for least needed privileges model of zero trust?
Wow, that's an interesting question. Let me try. If I get you well, my experience with automated tools is that, one, many organizations or many individuals who are in charge of running these processes do not make use of the tool. Maybe they are not aware of its presence or existence. For example, the primary Amazon tool for tracking logs and generating visibility from the different access, identity and access management activities has about 16% global usage. So Amazon makes available a free tool to give you visibility into your infrastructure and your users. And in the world, only 16% of their customers use it. So there could be a knowledge gap, meaning that people go to the cloud and implement cloud solutions, but have not had the appropriate training to actually know what is available and how to use it and how to make it work for the organization, because an automated tool will only go so far. It might not do the work for you. But in a scenario where you make use of the automated tool from a point of technical and subject matter expertise, you are able to, for example, in the case of Capital One, they could have been able to find this vulnerability and mitigate it, block it automatically by using an automated tool. And here's the irony. They have a tool that they developed as Capital One and donated to the community, the cloud open source community. That tool does exactly that. But they did not use their tool to save themselves or to secure their own infrastructure. So there is so much in terms of tools. This particular tool, if you're interested, is called Cloud Custodian. So Cloud Custodian simply scans your cloud instances every day or every night, finds out the ones which are insecure or the ones where users have been created and last logged in maybe 5 days ago or have never logged in. And then if you want, it will disable them, to delete them, to disconnect them from the network and give you a report. And it will work maybe across Amazon, Azure, and Google Cloud. And that is automation and orchestration, because you give it a policy and it implements the policy and gives you feedback. But if you do not know the tool exists, or if you do not use the tool, or if you receive the alerts from the tool and you keep them in a certain folder in your Outlook, and maybe you have 2,000 unread emails from the tool, then there's a gap between the capability and the actual use of that capability to achieve the security objective. So knowledge or know-how, and then the actual implementation are those two things that I find many people fail when it comes to automation and orchestration of security policy.
Thanks, Bernard. We have two more questions.
Are they the last questions?
Yes. Well, for now, we'll answer this if nothing else comes up.
Because it's about to be dinner time for some people.
Yeah, anyway, looking at our time check.
If we are working from
20
home.
minutes. Well, so we have a question from Nicholas. He says, with the risks surrounding cloud computing, is the National IT Risk Management Framework robust enough to accommodate these risks? Then, okay, maybe I'll just give you both of them at once. Then we have another one from Doreen, who is saying, how can we manage web filtering when accessing remotely on unmanaged wireless connections, but on company devices?
Okay, I'll start with Nicholas. The National Information Security Framework is I think it's sufficient in terms of as policy, the policy and direction, strategy and the policy are sufficient. The standards, I believe, are sufficient. It's now a question of implementation. Implementation is, I think, work in progress. It has taken long, maybe too long. It's a function of resources and maybe ability to execute based on work plans. Sometimes resources are present, but execution is also another story. So I would say as a country, we are in the execution struggle. We do not have a shortage or any problem with the guidance, the strategy, the direction, and the policies. We have to work on the implementation. We have to make sure that the execution is perfect, or it brings the desired benefits, the desired risk management to bear. That's my understanding of our national information security situation. Then when accessing Wi-Fi from company devices, it's important accessing unsecured Wi-Fi or home Wi-Fi or non-company Wi-Fi outside the organization from when using company devices. It's important to, one, have a security policy in place, and then that security policy is implemented using security software. So you typically have an endpoint security client on your computer, which, among other things, determines that you are on an untrusted VPN, untrusted Wi-Fi. And if that is the case, it will create a VPN to secure you on that untrusted Wi-Fi. And it will also create a firewall with appropriate policies to secure you as you're on that Wi-Fi. Many organizations will require that the connection is such that the VPN is back to the organization's firewall, and then all internet access is through the organization's firewall to prevent you from accessing unauthorized or dangerous content. So there must be a policy that determines the most appropriate action in terms of the risks that you face on unsecured Wi-Fi, and then that policy must be implemented by your devices, and then that should give you appropriate protection. But if you do not have all those things in place, I recommend that you make use of free, in consultation with your IT department, make use of free personal firewall software like Sophos or any other legitimate brands, which will give you the ability to have a VPN and be secure when you are operating on open Wi-Fi or insecure Wi-Fi. That's my advice.
Thank you so much, Bernard. We are coming to the end of our session. I don't know if we still have some more questions from the members.
Okay, I think we should wrap up and call it an evening.
We call it an evening. Wow. Thank you so much, Bernard. Well, I must still say that the presentation was very informative, and I know we've all learned a thing or two about how to go about our cloud security risks and how to mitigate them in case of, anything. We shall surely refer to some of these, or at least reach out to you to give us some insights on how to go about the different scenarios we may come across. Thank you so much, everyone. We'll just remind you about some upcoming events. We do have a data analytics training that is scheduled for April between the 28th and 30th. And it all depends on how the situation will be. If it's favorable and social distancing is, not as bad as it is now, we shall have both the online kind of meeting and in person, and this is good because it helps us to network. Then we also have a She Leads event where it was supposed to take place this month, but was cancelled because of the pandemic that we are all aware of, the coronavirus, but we'll update you on any other scheduled dates that we have. And maybe just remind us well to be ready. We have our next CPD will be on the last Thursday of April, and it will be on personal branding. That will be on the last Thursday is 30th. It will be on the 30th of April. And yeah, well, I think that's it. For all the other events that will come up, we'll be updating you through our social media and through your emails. Thank you so much, everyone, for attending, and have a nice evening. Our communications director, Mr. Jimmy Ayeke, has something to share with us, a communication coming through to the members. Jimmy, are you there? Jimmy? Jimmy?